This lesson is going to be an application on distance and slope. The title of the lesson is Coordinate Proofs with isosceles triangles and right triangles. Okay, so number one, the definition of an isosceles triangle. Okay, so I'm not going to assume that you know what that is. A triangle with at least two congruent sides. It could have three. So all equilateral triangles are isosceles, but only some isosceles triangles are equilateral. And you have a right triangle is a triangle with a right angle. All right. In order to have a right angle, you have to have perpendicular sides. All right, so in question one, we're going to prove that triangle ABC with coordinates A 1 0, B 1 4, and C -6 2 is an isosceles triangle. So I plotted it here. You can see it looks isosceles. It looks like AC and BC are congruent, but we have to use the distance formula to prove it. So we have to find the measure of BC and the measure of AC. I will put some graph paper on Google Classroom that you can print out for yourself that has this grid that I have here. Okay, so for BC, I'm looking all the way at the top of the page. I have to subtract the x's, so I have 1 minus -6 squared plus 4 minus 2 squared. So that's 7 squared, which is 49, plus 2 squared, which is 4. So that's the square root of 53. Now let's look at AC. So for AC, I have 1 minus -6 squared and 0 minus 2 squared, which is the square root of 49 plus 4 again, square root of 53. You have to write a concluding statement. That's the part that's the most difficult. So triangle ABC is isosceles because AC is equal to BC. That means the lengths are equal. That's all you have to write. Okay, let's take a look at another way that you could write this. You could make a flow chart. So you could just say AB equals CA, therefore, this arrow means therefore, you have an isosceles triangle. So if you don't feel like writing sentences, math is your friend because you can use symbols and symbols represent sentences. All right, so in question 2, given triangle JKL with coordinates J 0 4, K 8 5, and L 2 1, prove triangle JKL is a right triangle. So I'm just going to plot these points first just so I can see what it looks like. Now you don't have to plot these points. So if you want to, you can just do the entire proof without it. Because one thing about math is that they're asking you the question, right? Well, the Regents people aren't going to ask you a question if it's not a question that can be answered. The reason I like to draw a picture is because I can see that the right angle looks like it's at L. Those look perpendicular. It looks like JL is perpendicular to LK. So it just helps your intuition. So I'm going to get the slope of JL. Now I haven't done the counting method with you. We can do the counting method. So just to show you, you could go like this. The slope of JL is rise 1, 2, 3, run left 2. That's -3/2. Okay, so then we have the slope of LK. Do this one in blue. So for LK, I have a rise of 1, 2, 3, -4, because I'm going down 4. And then I have a run of -1, 2, 3, 4, 5, 6, because I'm going to the left. That reduces to 2/3. So do you see that these are opposite signed reciprocals? Writing it out is a little bit of a pain in the neck. So what you would say is, since the slopes of JK and LK are opposite reciprocals, JK is perpendicular. That's the symbol for perpendicular to LK. And then you would say perpendicular lines form right angles. So angle L is right. And then last, you would say triangle JKL is right because it has a right angle. Okay, if you don't want to write all this out, okay, you could do a flow chart. You could say slopes JL and LK, opposite reciprocals. You don't even have to use complete sentences. Okay, so then JK, perpendicular LK. Then you have angle L, right, and then you have right triangle. So it's the same thing. It's just a flow chart way of doing it instead of writing it in sentences. Okay, and that completes lesson 5. All right, I kept it nice and short and sweet. Thank you.